Welcome to part one of Competency 18. In this competency, the teacher understands how to plan, organize, and implement instruction using knowledge of students, subject matter, and statewide curriculum. That would be the Texas Essential Knowledge and Skills, or TExES or TEKS, to teach all students to use mathematics. This competency is part of Domain 6, which is 16% of your examination. In this video, we will work with planning strategies. Number one, a teacher is planning a unit that combines a student's knowledge of shapes to learn percents and review fractions. The first lesson uses the following shapes: equilateral triangle, rhombus, trapezoid, hexagon. Which of the following would be the best approach to provide a venue from the for the movement from concrete to abstract? Okay, let's focus on concrete. Let's begin with that. That would have to be something physical in front of the students. By definition, that would not be images, meaning it would not be a computer program. Okay, so put that in your brain. Okay, all right, let's read A. The teacher will provide the students with images of shapes while asking the students what improper fractions can be what improper fraction can be created with two particular shapes. No, images, that doesn't suffice, okay? The students will draw the shapes listed. No, you do not want them drawing the shapes. I could think of many things that could go wrong just in trying to get them to draw them correctly. That would be interesting. I'm rather they don't describe an activity that would get the students to draw them correctly. Okay. All right. So let's look at C. The teacher will provide the students with a set of pattern blocks. Okay, I like it. With the shapes listed above, the student will engage in a self discovery activity to find the improper fraction that can be created with two particular shapes. I like it. So I'm going to say C. Let's look at D. The students will use the list of shapes and select the two shapes that create given fractions. Okay, that doesn't make sense because there's tons of things missing. They need to be proportional. They need to have that proportion. And what do I mean by that? So I'm going to mark that out and I'm going to go down and just show you what my thought is. So you want to go from concrete to abstract. So I've put these images in here. So the glitch is that you're going to need the shapes to be, proportional so that you can do this. So I created these so that here, let me make sure this one is on top really quick for you. Let's bring that guy to the front. Okay, so we can see this. We can see that this one is half. See, I'm kind of making it work. All right, so this would be one. There would be two of those, so that would be 1 out of 2. So that's why my thought is you need pattern blocks to do this. They would need two yellow ones. Then for the green triangles, they would actually need 6 of these. See how that would work out? Okay. Right. But as you can see, even my images are not perfectly shaped. So you're going to need pattern blocks. Yes, you can go from pattern blocks, do an activity. And then from the pattern blocks, once they know how it works, then you can go to computer program, which I'm sure your district has it. I'm sure you have pattern blocks somewhere. And I'm absolutely sure that you have a computer program that the kids have access to. Okay. So that definitely would be a great activity. Okay. I'll move this out. And of course, this is your rhombus. So your rhombus, he's going to have to move in a way real quick where the students can see that you've got three, three to make one hexagon. Okay, so I'm taking a little time. But, see how I'm just moving it around? And that's just something, if they have it in their hands and they're doing it, that's your concrete. And then I'm using images. As you can see, you can do another activity with a different image or review it, whatever. But that gives you the idea and proves that C would be the best choice. Okay, let's move to number two. Number two, an eighth grade math teacher has asked her students the following question: what is the equation of g of x if the graph of f of x equals x to the third is shifted down 2 units? Okay, there's a lot to unpack there, but let's look at the question. Which of the following would provide struggling students accessibility to the concept described in the question? Okay, first, you're always going to have, there's just some standards here. F of X is generally where we begin, and this is a parent question. So I'm sure you've gone on over that. And then G of X would be the result. You kind of have to explain that to you. And then the action is it shifts down 2 units. Well, down is negative, okay? And I'm going to assume you've gone over this with the students. The student may not be visualizing. So the best thing is something where they can see it right then and there what happens. And if they put in other shifts, like kind of guess and do a different shift, would it result in what they needed? Okay. So let's see. Allow the students to use graph paper. Oh, no, I don't like that because, again, you're relying on them. It says accessibility. So they're going to struggle just drawing that first. Who knows how long it's going to take them to get to the actual concept that you want to teach right then. So that would not be a smooth move for a teacher to make. Okay. So if they're already a struggling student, remember that. Don't give them another test. It's going to make them struggle even more. Doesn't make sense. Okay, so let's look at B. Provide an image of f of x and g of x. Well, that gives them the ending result, but it doesn't quite connect the dots. You still would have to connect the dots. I've tried little things like this before, to see if they could connect the dots on their own. The non struggling students would have already imagined, they can already visualize it. They'll get it, they'll look at it, and they're done. Okay, so that doesn't help your struggler. All it does is help the connection for the ones that have mostly got it anyway. So that's not going to work for me. Let's see what C says. Allow the students to use a graphing calculator. Now that could help. That could actually help, maybe with some other things. You've already gone over some other elements, some other, things that you could have. There should be posters on the wall, hopefully, cross my fingers, that would be in the room. Okay, so this one would probably be the best for me, but it may not be the best because we need to read D also. D says, provide the students with a formula sheet showing the vertical and horizontal shifts. Well, that should have already been gone over and that should already be on their desk. But that's not what's going to help a struggler. Those formulas might be something that you can attach it to, but it's not going to do what it says here. Accessibility. That's the key. Accessibility. So I would say that, yeah, you better have those prior knowledge things out, but I'm going to say a calculator because that gives them something to test their other thoughts with. They're thinking, okay, shifting, because you have another kind of shift, not up and down, you have left and right, and they might confuse that. Okay, so this will help them get a little further. Number three, let's move it up a little here. Okay. A mathematics teacher asked a student the following question. Use the image below to answer the following question. Okay, so here is our intersection, and we have our angles formed. If the measure of y is 7 times the measure of x, what is the measure of z? Okay, which of the following statements would best describe a method of discovery that would give the students visual representation of a formula that would help find the value of z? Well, that's a lot to swallow. It just seems like a lot of words. Okay. Okay, so what are they asking? They're asking to develop a formula that would give you what Z would be. Okay, using here, so let me highlight using these two guys. Okay, so first, you know that Y and Z are equal to each other. Okay, and the students would have to go through some kind of a self discovery. Okay, and there is a way to do this and teach this. This is possible. So, what would the first thing be? The first thing is that the students would have to know that a line is 180, and they would also have to know that y and z are equal. We already stated that, and that Z plus X equals 180 and Y plus X equals 180. Okay, great. All right, let's read our ABCD and see what they have to say. Okay, allow the students to use a protractor. That is not a good self discovery. That's just simply an estimate of the values. That's not going to work. Okay, all right, so let's mark through that. All right, give the students' notes with the laws of alternative angles. Okay, that's going to help them, but it's not going to be a self discovery activity. Maybe it should be included in the activity, but that's not going to help. Okay, so let's look at C. Allow the students to use a graphing calculator. Well, that'd be great if they had a formula to put in it. And so obviously that doesn't help. So hopefully D's what we need. Provide an activity using patty paper that creates angles which represent X and Y. That I agree with. And there is an activity out there. You can look these up on YouTube. They exist. So, and if you haven't used patty paper, when you're dealing with anything that can be even mildly geometric, symmetric, any of those things, or just see through it on their computer screens. We're very digital when we test now. So that will be a little quick secret weapon for you as an educator, patty paper. So I'm going to go with D. I absolutely agree with it. Now, they even make the patty paper that is, patty paper is literally for hamburger patties, right? Patties that you eat. You would literally buy it at the grocery store. Okay. I do believe I found some at HEB. Walmart's even had them, whatever. Okay. The thing is now, out there in the realm of education, they make a patty paper. It's a wax paper and it has a sticky portion on it for convenience. So, like a little sticky pad. And you can use it if you're not out there in education, you haven't seen this yet. Go find you some. It's amazing. So you stick it on the computer screen. Now, the kids are not going to have a touch screen for them. They shouldn't. Every now and again, they give a kid a touch screen. Usually the touch screen is for the teacher, which is not a good thing when you're using patty paper, okay? Because then the screen moves around. But it's great for your students and their little Chromebooks. You stick it right on there and see through it. And then if you get the non-sticky one, and this is the activity they're talking about, you can have them fold the line just like what you see and literally go through the motions to see what that formula would be. And of course, this one's very convenient. This would be a great activity. Why? Because we have 7 plus this other angle. So really there are 8 angles. So you could just go through the motions of folding it in half and then folding those in half and then folding again. So you have 8 folds. And then you can go through, well, this would be the value of y, and this would be the value of z, and this smaller one would be the x. So let's go, and you can just walk them through it. And that way they at least have some kind of a visual, and something in their hands. Okay, little more concrete and not so abstract. And then when they go to future questions, it'll be easier for them. Okay, I think I've said enough about that. But yeah, look up patty papers if you haven't. And if you've used them, you'll agree with me. They are very helpful. They have more than one use. Okay? All right, let's go to number 4. Number 4, use the statement below to answer the following question. What is the distance between the point -2, 4 and the point 5, -7? Which of the following activities would help illustrate a relevant application of the Pythagorean theorem? Okay, so what that's saying is relevant means real world. Okay, we have the students do these things on with calculators and graph paper and a variety of like with the Pythagorean theorem, we use as concrete, we use the tiles with the triples, but that to them is not relevant. How does that apply to the real world? And they're going to ask you, and that's a really good question. So if we give them activities where it's the actual real things that they would come across in their life, then it'd make more sense. So now that I've said that, let's read our options and see which one of these would do that. Okay. A, provide an activity where students use graph papers to draw. No, we do that all the time. They get so much of that. There's all kinds of treasure hunts and things we've got out there as educators. So that's not going to help. B, model the distance formula before students complete activity involving the question above. No, that is just connecting one formula to another formula. So that's not going to help with real world relevance. Okay, C, provide students with an activity that incorporates the coordinate grid over a baseball diamond image and the use of the Pythagorean theorem. I like that one. And in one of my prior videos, there was actually a question like that. Uh, so you can take the diamond and you can have someone out in, say behind first base, okay? And then figure out the distance from how far would they throw it using the grid and the baseball diamond, a relative position of one person to each base. Now, that would make sense to a student, okay? So, and by the time they're this age to learn the Pythagorean theorem, doing that would not be such a stretch. Okay, of course, if they're really younger kids, you would never do any of this. Okay, not with the Pythagorean theorem, of course. All right, let's look at D. Modeling the Pythagorean period using the given point on the coordinate grid. Okay, again, that's just like more graphing without relevant situations. So, I mean, it's good practice, but it doesn't put things into perspective for kids. Now, another thing I just thought of, which would help, taxi cab geometry. Okay. So introducing a little bit of that, like a city plan with the graph over an actual drawing. Okay. And then asking them relevant positions and having them go through that. That's what city planners do is taxi cab geometry. When you have streets that are drawn on right angles, what are you going to do? Now, not all streets are right angles. If you've been to DC and I grew up in a little town that we had the hypotenuse going into town, through that's not how it was. You could literally just drive straight into town. But anyway, that's another story. Anyway, that gives you an idea what they mean by relevant. Something that, hey, when would I ever use this? Well, these are times when we do use this, okay? All right, so let's look at number 5. Okay. A high school statistics teacher wants to provide students with a practical example of a data set that it illustrates the normal curve. The teacher gives the students a probability simulation activity that requires the students to collect data relating to the height of the students in their high school. Okay, I could see it. So they're going to have a little survey and they're going to go around and they're going to pick so many people at random to ask them their height. Okay, that would make sense. Which of the following is the best type of collaborative grouping for the activity? Okay, now you got to think about the situation and what would be most practical. And we're talking about an activity where you give them a certain amount of time, and how would that best be used? So let's look at A, B, C, and D. Okay. Students, and what I'm talking about A, students should work independently to gain the most benefit. No, I would not let them work independently. You would never get it from them. There would not be that collaboration with one person pushing another person to do the work. Okay. I would say no to that. No, I don't want to. They always say I want to work independently. Very rarely that does. I mean, very rarely does that work well. Okay. All right. Let's see B. Groups of 4 would be the most efficient group since this is a data collecting activity. I disagree with that because you just need someone collecting it and writing it down, and it would be a sampling. Okay. And that being said, you're just sampling. No, I don't like that. Uh, yeah, because you could have, because what would happen is one person asks a question, one person writes it down. One person, and they would have to work together. I mean, if you have 4 people, I don't see that. I see too many people trying to collaborate. I see 2 going off together and 2 going off together, or one person being left out. I don't think there's enough work in that, asking question, writing it down, to justify 4 students, okay? So I'm not going to go with that one, not for this activity. Let's look at C. Students should work in pairs so that the students can assist each other in collecting and recording the data. I see one person for collecting and one person to help record, and then feeding off of each other. But a group of 4, I have noticed that groups of 2, groups of 3 can work, but groups of 4 are not always good. And grouping your students and grouping 4 in the classroom, you're going to have to play with it, but I find that 4 doesn't work the best. And you have too many people to pull together, and students don't do it well. Okay. All right. We're talking about young students. So I'm going to say C is the best answer. Let's look at D. In this instance, this should be a whole group activity with each student in the class having a role. What? There's not enough roles. No, I don't like that. Now, when for this activity, and we're talking about 2 students being the best, well, yeah, no matter what, and I'm thinking it out, yeah, 2's the best. Now, when they get their data and they collect their data, then maybe they could come back where 2 of them collect data and then the other 2 they do it and then they bring it into a group of 4 or 3, and trade off, trade what they've got done. I mean, I'm trying to brainstorm what this will look like, and I just don't see for middle school students. If for high school, yes. And it says high school. So, yeah, two students. If it was middle school, even two students. Yeah. Okay. Anyway, I've tried to think that one out. I think I thought through it too far. Anyway, that's the last question in this video. I wanted to thank everybody for watching and making it to the end of another video. And kudos to those of you who have liked us, shared us, and subscribed. Thank you for watching. Happy testing, everyone.